Hello everyone and welcome to this module on continuum mechanics. So basically in the previous video, we derived the equations for F, B, and C tensors in uh, the cylindrical coordinate system where we had the cylindrical coordinate for both the reference and current configuration. So using that as strategy and using that video, you will be able to derive the relevant strain tensors for the spherical coordinates. But in this video, we are going to use different coordinates for both the reference and current configuration. So they are not similar. For this one, I followed what the book actually presented in this section. So here we have the Cartesian coordinates for the reference configuration, and then we have the cylindrical coordinate for the current configuration. So by using this strategy, which is quite similar to the previous video, you will be able to derive different strain tensors for different coordinates in both reference and current configuration. So if you follow what I do here, you will be able to establish the strain tensors for example, spherical coordinate in the reference and, for example, Cartesian coordinate in current configuration, or any possible kind of, combination of Cartesian, spherical, and cylindrical, or any kind of, curvilinear coordinates. All right, so with this in mind, let's get it started. So we already mentioned that if you have your elements in the reference in the current configuration, so you can use a tensor like f, which is a deformation tensor, to transform this element in the reference configuration to the current configuration. All right, so here we have dx. Since we are in the current configuration, this dx is the current configuration, we are in the cylindrical coordinate. So we have dr er plus, and this is also a vector. This is, sorry, r d theta e theta plus dz, then ez. So but I'm gonna remove these heads in here and also this this area in here. But remember that these are the unit vector basis, and here we have the element because it becomes very complicated and nasty when I write all the equations, so I'm gonna just remove these heads and these arrows in here. So we have this dx in here, where we have the reference configuration, and we are in Cartesian coordinates. So we have d capital X, e capital X, plus dy. This y is also capital, e capital Y, plus d capital Z, and this e capital Z. And here, notice the difference between this capital Z and this small z. So I put a horizontal line here to distinguish between the capital and the small z. All right, so when we say that we have the reference configuration for the Cartesian and the current configurations for the cylindrical, then we know from previous we have small xi is equal to small xi, which is a function of x, capital J and T. And here we have the cylindrical coordinates for the current configuration. Therefore, we're going to have r, small r, is a function of x, capital Y, and capital Z and T. Theta is a function of capital X, capital Y, capital Z and T. And small z is a function of capital X, capital Y, and capital Z, and then T. All right, so let's get started by the component by finding f, the deformation tensor. So if I write this equation again here, so we have dx is equal to f f d capital X. So we're going to have something like so this dx here is the cylindrical coordinate. So we're going to have these components here. So dr r d theta, and then we have the small z is equal to. Then we have f in the matrix form. So we have frx, fry, and frz. And remember here, notice that we have the first one is for the current configuration, the first subscript, and the second subscript is for the reference configuration. So if I just point this out in here, that we are talking about the current configuration, and here we have the reference configuration. Okay, then we have f theta capital X, f theta capital Y, f theta capital Z. And then we have f small z x, f small z y, and f z small z capital Z. And then we have this dx in here is this one. So we have d capital X, d capital Y, and d capital Z. All right, so next dr is equal to this line, this row times this column. So we have f r x dx plus f r y dy plus f r z dz. And then we know here that r is a function of capital X, capital Y, and capital Z. So dr is equal to the partial derivative of r with respect to capital X dx plus partial derivative of r with respect to theta, capital Y dy plus partial derivative of r with respect to capital Z dz. So if we compare these two together, then we get frx here, which I'm going to write er dot f e capital X is equal to the partial derivative of r with respect to x. Then I have fry, which I'm going to write er dot fey is equal to partial derivative of r with respect to capital Y. And then finally, we have frz, which is er dot fe capital Z is equal to partial derivative of r with respect to z. All right. So then I need to find the second row, which is d theta. So d theta is equal to, it's r d theta. It's this one. It's equal to this row times this column. F theta x dx plus f theta y dy plus f theta z dz, d capital Z. And here, if I divide all of these by 1 divided by r, then I also know that d theta is a function of capital X, capital Y, and capital Z and t. So I have d theta is equal to partial derivative of theta with respect to capital X dx plus partial derivative of theta y dy partial derivative of theta with respect to capital Z dz. And by comparing these, I get f theta x, so it's e theta f e x is equal to, so r goes in here, so r partial derivative of theta with respect to x, then e theta dot f e y is equal to r partial derivative of theta with respect to y, and then I have e theta dot f e z. This is capital Z. Yes, this is capital Z. is equal to partial derivative, it's r, partial derivative of theta with respect to z. All right, so next we have the small z. So I pause the video and I write this, so you can check with me after I resume. All right, so I wrote dz, which is the product of this row in this column in here. Then I know z is a function of capital X and Y and Z. Then I wrote down this in here and then compared these two terms and I wrote these in here. All right, so next I have to find f(ex). So f(ex) is equal to f. If you remember, we when we transfer the unit basis, so we had jx ej, which is equal to f rx er plus f theta x e theta plus f sigma z x e z. This j in here, since we have capital X in here, so we have the cylindrical coordinate, the current configuration here, because we are going to transfer these from the current configuration to the reference configuration. Then j takes r, theta, and z. So then f e capital X is equal to, so frx is this one, partial derivative of r with respect to x er plus f theta x. F theta x is this one, so r partial derivative of theta with respect to x e theta plus fzx. Fzx is this one, so it's the partial derivative of z with respect to basically x e z. So this is the first equation that we need. Then I also write f e y and then f e z, and you can check after I resume. All right, so here is f e capital Y, and here is f e capital Z. So I have to also add in here that here I already mentioned that we have current and reference configuration, and this one in here is basically E, R, ER, E theta, and EZ. For the current configuration, I guess that it is in here. So here I have ER, E theta, and EZ for the current configuration, and for the reference configuration, I have E capital X, E capital Y, and E capital Z in here. So you have to bear this in mind that this F, the first subscript it refers to the cylindrical coordinate, the current, and the second, it refers to the Cartesian or the reference configuration. So next, we need to find the components of F transpose. So in order to find F transpose, we can use the things in here. This matrix, this tensor, second order tensor in here. So I'm going to grab all of these, copy, and then paste it here. Okay, this one, then this one. All right. So for the moment, I'm going to get rid of these. So here I can write this as f e capital X, that er is equal to e capital X f transpose er. This was equal to partial derivative of r with respect to x. It was equal to this one. Okay, next I have f e capital Y dot er is equal to ey, oh, sorry, it is f, no, it was correct. It was ey dot f transpose er, which was equal to this one, partial derivative of r with respect to y. And then I can write this as f capital Z dot er is equal to ez f dot f transpose er, which is equal to this one, partial derivative of r with respect to z, capital Z. And from here, I can simply calculate. So I can calculate f transpose er. So I have f transpose er here. So I can write this as j r e j, where j here is x, capital Y, and capital Z. So it becomes f x r e x plus f y r e y plus f z r e z. Okay, so I have f transpose er is equal to fxr. This is transpose, of course. Got. So this is f transpose xr is this one, partial derivative of r with respect to x, e capital X plus yr is this one, f transpose yr, partial derivative of r with respect to y, e y plus, this is f transpose zr, it is this one. So this is equal to f transpose, oh sorry, it is partial derivative of r with respect to z, e capital Z. So I have this, and then I need to find also f transpose e theta as well as f transpose e z. I will write the relevant equation following this procedure. They already did in here, and you can check later with me. All right, so here we have f transpose e theta, and then we have here f transpose e small z. All right, so now have all the ingredients we need for calculating B as well as C, because in B, if you remember, we had B was f transpose. So we now have F as well as F transpose. Actually book used the found B components with respect to the current configuration, and I'm going to follow this current configuration, but you can also calculate this with reference configuration. All right, so now let's find, for example, b theta z. So here you have ez dot b e, sorry, b e theta b e z. So this is e theta dot f transpose e z. So we have e theta dot f transpose e z. We have to first find f transpose e z. So f transpose e z is this one in here. Copy this, and I write this again here. We have e theta dot f. Then I paste this in here. Let's make it black. Right. So this becomes partial derivative of z with respect to capital X, e theta dot f e capital X plus partial derivative of z with respect to capital Y, e theta dot f e capital Y plus partial derivative of z with respect to capital z e theta dot f e capital Z. Now we need to find these components in here where we have them in here. So, and the dot product with E theta. So so we have F, here they are, F EX, F EY, and F E capital Z. If I'm not mistaken, it's true. And we need to find E dot, and E dot of this, dot product with these expressions here. And since we have E dot, so we only need the second term in each of them. So R theta, so it is equal to partial derivative of theta with respect to x plus the first term here, then R partial derivative of theta with respect to y plus partial derivative of z with respect to capital Z, R partial derivative of theta with respect to z. All right, now let's calculate for example, C. And the book actually used with respect to the reference configuration. All right. So in order to find C with respect to the reference configuration, you remember we had C, it was equal to F transpose F, and we have all the ingredients. So for example, let's find C x capital Y. So here we have to write EX dot CEY. So we have EX dot F transpose FEY, which is equal to EX dot F transpose. Now we have FEY, we need FEY. So let me just write this in here. So we have EX dot F transpose FEY, FEY, it's here. So we need to take this, copy FEY, paste it in here. Then we get EX dot, sorry, partial derivative of R with respect to Y. Then we have EX dot F transpose ER plus R partial derivative of theta with respect to Y. EX dot F transpose E theta plus partial derivative of Z with respect to capital Y. Oh, sorry, this is E capital X F transpose E Z. Now we need these components in here. So F transpose ER, F transpose ER, and the dot product with EX. F transpose, here you go. EX dot this, EX dot this, and EX dot this. And since this is dot product, so we need the first term of each. So here we have partial derivative of R with respect to Y, and this is capital Y, sorry, Y. And this one is partial derivative of R with respect to capital X plus R partial derivative of theta with respect to capital Y, R partial derivative of theta with respect to X plus partial derivative of small z with respect to Y. And let's write it like this. Then we have the partial derivative of z with respect to X. Let me check if this is, yes, small z. Okay, we have z and z in here. All right. Now let us get to B inverse and C inverse. See, B inverse with respect to reference, with respect to current configuration. So you already know that B inverse is basically F transpose inverse, which is equal to F transpose inverse, where we write it F inverse transpose F inverse. So if I can find F inverse and F inverse transpose, then I will be able to calculate B inverse, and then C is somehow the same because it follows, F transpose F inverse. So we can also calculate different components of C inverse. So for here, you know that we have dx is equal to d capital X is equal to F inverse d small x. And here, since we have, Cartesian coordinate for the reference configuration, then we'll have capital X is a function of r, theta, z, and t on this side, and y is a function of r, theta, and small z and t. And then z, capital Z, is a function of r, theta, small z, and then t. So if we write down this in here, d capital X is equal to F inverse, yes, dx is equal to, is equal to, so if I just bring this a bit down, all right, so we have d capital X, d capital Y, d capital Z. Then we have in here F inverse XR, and remember here, the first subscript is it refers to the reference configuration, and the second it refers to the current configuration. F inverse X theta, F inverse X Z. This is small z. F inverse capital Y R, F inverse capital Y theta, F inverse capital Y small z, and F inverse capital Z R, F inverse capital Z theta, and F inverse capital Z small z. Then we have our dr, rd theta, and then we have dz. All right. So from here, I can calculate dx by multiplying this row and this column. So I have F inverse xr dr plus F inverse x theta r d theta plus F inverse x small z dz. And I also know that x is a function of r, theta, and z. So I have partial derivative of x with respect to r dr plus partial derivative of x with respect to theta d theta plus partial derivative of x with respect to small z dz. And if I compare these two, then I get F inverse xr, or ex dot F inverse er is equal to partial derivative of x with respect to r, and then I have F inverse x theta, I have ex dot F inverse e theta equal to, I have an r in here, so 1 divided by r, partial derivative of x with respect to theta. Then I have F inverse x small z, which is ex dot F inverse ez, is equal to partial derivative of x with respect to z. All right. So now if I draw two lines in here, as well as here, I will be able to find the rest of elements using this strategy. I will pause the video. All right, so now I filled in the rest of the components for F inverse tensor. And now we need to find F inverse transpose, because we need F inverse as well as F inverse transpose. So for F inverse transpose, I simply copy this from here. I paste them here. Then shift this to the right. So here I can write this as F inverse ER dot EX, which is equal to ER dot F inverse transpose EX is equal to this. F inverse E theta dot EX is equal to E theta dot F inverse transpose EX. And then I have F inverse EZ, E small z is equal to, dot EX is equal to EZ dot F inverse transpose EX is equal to this. So bring this bit to the left. Then I have this in here. So from here, I will be able to calculate F inverse transpose EX simply. So easily. So I have F inverse transpose. Here I have JX, EJ. And here, J is R theta and small z. So I have F inverse transpose of Rx ER plus F inverse transpose. I have theta x E theta. Then I have F inverse transpose. Then I have Z capital X EZ. So F inverse transpose EX is equal to F inverse Rx, which is this one. So capital X with respect to R, ER plus F inverse transpose theta X, which is this one. 1 divided by R, partial derivative of X with respect to theta, E theta plus F inverse ZX EZ, which is ZX EZ, is this one. So partial derivative of X with respect to Z, E, Z. So I can find the rest of, expressions for F inverse transpose EY as well as EZ. I will pause the video now and write them all down. All right, so now we have the equations for F inverse transpose EY as well as F inverse transpose EZ. So now let's find, for example, B inverse R theta in the reference in the current configuration. So we have ER dot B inverse E theta, which is equal to ER dot F transpose inverse E theta, which is equal to ER dot F transpose inverse F inverse transpose, then F inverse, E theta. So now let's find F inverse transpose. So ER dot F inverse transpose, and here we need F inverse E theta, F inverse E theta. So I haven't calculated F inverse E theta, but you can simply find it from here, F inverse E theta. So let's derive them in here. We're writing this. So cut this. So here we need F inverse ER, F inverse E theta, and F inverse EZ. So F inverse ER is equal to F inverse JR EJ, which is equal to F inverse. Here, J is X, Y, and capital Z. So we have F inverse XR EX plus FYR EY plus F capital ZR EZ. These are inverse, of course. So F inverse ER is equal to F inverse XR, F inverse XR, which is this one, So partial derivative of x with respect to r, e capital X plus f inverse yr. F inverse yr is this one. Partial derivative of y with respect to r, e y, e capital Y plus f inverse zr. So f inverse zr is this one, partial derivative of z with respect to r. E capital Z. So now we have f inverse er. We can calculate f inverse e theta and f inverse ez. I will pause the video and write them down in here. All right, now we have f inverse e theta as well as f inverse ez. Now we can paste our br theta in here. So now we need f inverse e theta, which is this one. So we copy and paste it in here. So I get 1 divided by r, partial derivative of x with respect to theta, er dot f inverse transpose e capital X plus 1 divided by r, partial derivative of y with respect to theta, er dot f inverse transpose ey plus 1 divided by r, partial derivative of z with respect to theta, er dot f inverse transpose e capital Z. All right, so now we have to find these expressions. We already calculate them. F inverse transpose ex, f inverse transpose ex, ey, and ez in here, and their dot product with er. So it means that only the first term in here are required. So we have 1 divided by r, partial derivative of x with respect to theta, times the first one, which is partial derivative of x with respect to r plus 1 divided by r, times partial derivative of y with respect to theta, times this one in here. So it's the partial derivative of y with respect to r plus 1 divided by r, partial derivative of z with respect to theta, capital Z, and then times capital Z, partial derivative of capital Z with respect to r. All right, so you can calculate the rest of the components of B inverse using this strategy. And then C inverse. Let's find C inverse here with respect to reference configuration. All right, so let's find, for example, C inverse x, y. So here we have ex, C inverse ey, which is equal to x dot f transpose f inverse ey is equal to ex dot f transpose, f inverse, then we have f inverse transpose ey. So first we need to calculate this. If ex dot f inverse transpose ey, f inverse transpose ey, it's in here. So we copy this, paste it here, and let's make all of them black. So we get partial derivative of y with respect to r, ex dot f inverse er plus 1 divided by r, partial derivative of y with respect to theta, ex dot f inverse e theta plus partial derivative of y with respect to z, ex dot f inverse ez. So we need to find the dot product of ex with these components here, f inverse er, f inverse e theta, and f inverse ez, where we have this. So uh, since this is ex, so only the first terms are required. So we get partial derivative of y with respect to r, then this one becomes partial derivative of capital X with respect to r plus 1 divided by r, partial derivative of y with respect to theta times 1 divided by r, partial derivative of x with respect to theta plus partial derivative of y with respect to z times partial derivative of x with respect to z. And you can calculate the rest of the components using this methodology. So by this video, in this module, we basically finished this third chapter of the book and the second module of our topics covered. And in the next module, we're going to discuss different stress components and also the roots of stress.